Good afternoon, everyone. My name is Jacob Taylor. I'm the TEC Training Coordinator. As we take you around the lab today, you're going to see the gentleman standing beside me, Evan Jones from Cumberland County Schools. This is his second year in the Career Connections program for Cumberland Middle School. We're going to start off on this end of the room talking about some of the equipment that we have over here and what are some of those skills and career pathways that we highlight with this equipment. I'm going to turn the mic over now to Evan. He's going to take you guys through here and let you see some of the examples of work and the different things that you can do with these pieces of equipment.
So the first piece of equipment we're going to look at is the Dremel LC40 laser cutter. This is a CO2 laser. In the classroom, we introduce this by basically starting with the number of directions in which this machine is able to move. So you can think about this as an Etch-a-Sketch that rather than you're able to move in X and Y, but rather than placing a little dot there, you're actually burning a hole through something with a laser or engraving something with a laser. So this is able to move in 2 axes, so you can cut things like plywood or acrylic. You can engrave things. We use this as basically the first step in rapid prototyping, some idea from the back of a napkin to a real object. So I've got some examples I'll show here in a second after we talk about the 3D printer, but it is the first step that we use in, like I said, going from the back of a napkin to a real 3-dimensional object. So this lets us cut an object. It's fast. It's relatively inexpensive to cut something like this, and so we can train the kids in a 2-axis machine here. So moving from 2-axis to 3-axis, this machine moves in the X-axis, the Y-axis, and the Z-axis. So this is one of our Dremel 3D printers. So we have a couple of prints, cooking show style, that we have already started working on. And this particular print actually shows off one of the models that we use that shows the X-axis, the Y-axis, and the Z-axis. So that is sort of one of those tools to help us explain X, Y, and Z. So 3D printing is an additive process, by which that we mean we're starting from nothing. We're starting from a bare glass plate, and we're building material up from literally nothing. So with the 3D additive process, we can take with the 3D additive process, we can take something that we prototyped in the laser cutter and actually print a 3-dimensional object in plastic. We have a couple of different varieties of plastic we can use, but that gets us another step closer to a real product, a real thing that the kids can hold in their hands and actually use. So we have some examples of 3D printed stuff that has happened. Some of this is from once the pandemic happened, once things got shut down, we started manufacturing over in Cumberland County. We started manufacturing some various little accessories for personal protective equipment. So these we have printed by the hundreds. It is a little doodad to go around behind your head and hold the straps of your mask, keep them off your ears. This is a frame for a face shield. Now, 3D printing is not necessarily the most efficient way to manufacture these, but it is the easiest way that we had, short of buying a multi-$100,000 injection molding machine. We also toyed around with some 3D printed respirators, but moving back to the rapid prototyping sort of discussion, we needed a bracket at one point to replace this giant metal bracket thing. So quickly and inexpensively, when I say quickly, I mean in maybe 2 minutes, we're able to laser cut this, test fit it to exactly what it needs to do, make sure that it's going to fit. Then you can take, this is the side profile of that, so it's the side profile of that one. You can take this same file that you laser cut, and we can throw it to the 3D printer. Now this process is going to take probably 4 hours. So we're able to, in the classroom, prove an idea out. Is this going to fit? Is this the right shape? Is this, or do you have enough clearance? which on this one you can see that it didn't have enough clearance because it was rubbing terribly. And then we end up with another iteration, another iteration, another iteration. We keep going back and back and back until we have exactly what we want made out of plastic. Moving from there, we can move to another machine that is a 3-axis subtractive process. I'm going to hand over to Jake and let him handle that one.
Absolutely. Thank you, Evan. So with the 3D printers, not only are teachers introducing their students to rapid prototyping, but they can also use them to print different props or aids in their instructional process for different units that they're teaching. So this is an example of just an XYZ or Cartesian plane. So thinking of middle school students, they haven't really learned outside of the X and Y axis, they haven't really learned in that three-dimensional math kind of spatial concept. So we print these to help them understand how they orient themselves in 3 space and manipulate a 3D printer that moves in 3 space, or the milling machine here, the subtractive manufacturing machine we have here, how it moves in 3 space. And we go even into the robotics with this. So Evan has covered the 2D subtractive with the laser cutter engraver, the 3D additive process with the 3D printers. This is a Haas desktop mill. Each of our GoTech labs in our footprint will have at least one. A lot of them will have 2 of these in their classroom so that they can highlight the subtractive process and how running a milling machine with a computer numerical control, how that actually works. So we have a program currently set up in this machine that we'll run through. And the screen's going to prompt us to a couple different things. We'll get through here. We're good. I'll speed it up. So this program starts off just by facing the block to give us a very flat surface to begin to profile out our shape. And we have some examples of other work pieces over here. These are programs that the teachers can readily and easily bring up on the controller, put a piece of stock in their work holding vise, and with very minimal setup, they can go through and actually illustrate the subtractive manufacturing process. We have an 1/8-inch end mill right now running in the spindle of this desktop mill, so it takes it a little bit to actually face off this entire block. But once it gets through that, it's going to go through and actually start creating the profile of the shape that's in the program. So using Fusion 360, students get introduced to 3-dimensional design. They can use Fusion 360 to create files to print on their 3D printers. They can also use Fusion 360 to design a 3-dimensional object that can be subtractive manufactured. So this program was created through Fusion 360's CAD CAM. And it's almost done facing right now, and then it's going to start cutting out the profile. So right now on this machine, it's machinable wax that we have loaded in. And this is our smiley face program. All right, so that's going to keep running. We're going to kind of come on down the line. Once students manufacture something, we do talk about dimensional inspection and standards of measure. So each lab is equipped with digital calipers, with digital micrometers, and we are using these to do some dimensional inspection activities with the students. A new feature that was just released on Fusion 360 is actually a walkthrough digital inspection with their 3D model on the screen. So that's an activity that we're going to incorporate into the curriculum very soon. But it gives them an exact graphic of where they can measure, what tool they need to measure, what feature that exactly is, and they can input that into the screen. and it will print an inspection result sheet at the end of that entire process. So a really neat kind of culminating thing to use Fusion 360 all the way from the design part all the way to the dimensional inspection at the end. So another unit of the curriculum is automation and robotics. So we have the Dobot Magicians. These Dobots are a 4-axis machine. They have a suction cup fixed to the end of them where you can actually pick things up and move them. So this system with the conveyor in it has a couple other items. It has a photoelectric sensor, and it also has a color sensor integrated into it. So this simulates 2 robots working in conjunction with each other to do a pick and place activity on one end of the conveyor and then actually sort on the other. And Evan, that one's running. So we'll do a little demo of this. So the first Dobot comes in, picks up a cube, places it on the conveyor, and sends it down the line. And when that photo eye is tripped, the Dobot on the end realizes there's some work to be done, picks up the block, places it over the color sensor, senses its color, and sorts it accordingly. What's neat about the Dobots is in terms of IT coding and programming, you can use Blockly style coding, which is very similar to a Scratch program that a lot of elementary school students use. So it's a very visual program, but you can also go into your more abstract programming languages and scripts, such as Python. So the one on the end here is getting ready to get its second red block. Let's see if it realizes it's now going to have 2 in the system on this end.
One of the things we've done with my students in this this particular activity is that it's a fantastic demo, but then I have challenged my kids, let's make it run faster, let's make it run, let's put, instead of 9 blocks, let's put 2 stacks, let's put 3, let's find the upper limit of what these robots can do. One of the other challenges has been what happens when something goes wrong over here. So I'm going to, if this stack of blue blocks falls over, disappears, what have you, your system needs to be designed in such a way that it's able to deal with that. And right now, the stock demo that we have, it's not able to handle that fault. So the kids go through a process of refining this program to be able to tolerate those faults, to be able to be either more accurate or faster, or in a perfect world, all 3.
All right, moving on down the line, the last station we're going to demo for you guys today is our Lincoln Welding Simulator. So Evan is going to be jumping into the welding booth right here with the VR goggles. So using the Lincoln Welding Simulator, you're able to simulate all 3 welding processes of stick welding, MIG welding, or TIG welding. And then you can use different style coupons to weld on that simulate your different joints and your different welding positions. So right now we have this set up as a MIG process. It is a stringer push, and we can actually display the exact weld as it should be, a perfect weld for this particular process and setup. So from an instructional standpoint, teachers can show this first, and it demos the exact travel angle, work angle, contact tip to work distance, and the machine setup and everything all in one. So you can actually see one pass, what it should look like before the students do it. And again, this simulation went from right to left, and the software is smart enough to recognize that you can come from left to right. It would be the same weld. So we've got that pass. That was the computer simulated pass. Now we're going to return to welding, and we'll give Evan no pressure right here. No pressure. So
this particular screen, oh yeah, I can't see a microphone. This particular screen shows you exactly what the student can see in the VR goggles. So if I look at the welding coupon, you can see that there is a welding coupon there. You can see that the MIG gun is there. So it is a fairly accurate representation of what it looks like, what it feels like, aside from there's no danger from the electricity, there's no danger from the excess heat that welding creates.
And also inside of Evan's helmet, there's audio. He has earphones inside of that helmet, and the audio feedback is very important during the welding process because you can get ideas of whether you're too close to your workpiece or too far from your workpiece, or if you have your machine settings a little off. So we can watch Evan's view, and Evan got slick on us. He put on a few cheaters, which is good. When you're talking about a student learning the welding process from the very beginning, there are a lot of things that you have to keep in the correct position and at the correct distance in order to put down a good bead. So some of the cheaters that he has on are for aiming purposes or for spacing his contact tip from the joint, also his angle, his travel, and his work angle. And then the little speedometer on the end of that torch, that's a speed indicator to let him know if his travel speed is too fast or too slow. All right, so Evan has finished his pass. On the screen, we can go to end pass, and we can go to a grading screen where actually grade based on the criteria set up at the very beginning of the welding process. And you can turn different grading on, different grading off, different things you want to focus on. And it gives an overall score out of 100. Evan gets an 89.
I'd like to focus on the one aspect that I got a perfect score on.
The work angle. Yep. So his work angle held 100 the entire way. And again, that was set on the tolerances from the very beginning of booting this system. You can actually make it grade a little harsher if you know you have a student with a lot of experience. You can take that tolerance way down if you know you have a beginner and you want to encourage them to work on certain skills. Outside of the grading of the weld, there's actually another process of the inspection of the weld. It'll actually go through and tell you, do you have certain problems with that particular weld? Is it porous? Is it undercut? Do you have incomplete fusion between the two parts? So now Evan's just kind of simulating where you can actually do wrong instead of right. So what if you come through and you really do not pay attention to all of the components of laying a good weld? Yep. Work angle's still good, but now you're way down in the 50s. Yep.
So that shows that my position was all over the place. Obviously, as I'm waving the thing around, contact tip to work distance was all over the place. That's your distance in and out from the work. So it lets a student focus on individual aspects of this process instead of trying to get everything right all at one time. You can focus on getting your position right. Then you can focus on getting your work angle right. Obviously, apparently I'm better at work angle than I am at anything else. You can focus on different aspects of it. And then like Jake was saying, this will tell you if I had done such a weld in real life, what would be wrong with it. So there's incomplete fusion in this entire section here at the beginning. There's a poor bead placement as I'm waving all over the place. So it will tell them what is wrong with their weld, how such a weld would perform if they did something like that in real life.
Thank you, Evan. As we come back through, we'll check out our finished product over here on the CNC desktop mill. So we do have a complete smiley face on our machinable wax there. All right, and we thank you guys for joining us today. If you would like more information about GoTech, or if you would like to come and visit us in person, please check out our website at gotechva.org. And that is the conclusion of our live broadcast today. Thank you for joining us for the ribbon cutting.